video.
Alright.
Alright, here's our next example here, and that'll be our last one for today. So the complication here that you will meet will become evident in a minute. So let's start by factoring the bottom. I see there's a common term, so pull that out. So we don't care about the top. That is not the complication. This problem we work decompose just the same with a top like that as it will with a top like that. So that's not the complication that we're introducing here. So you'll see it in a minute. Let's factor the bottom. First you pull out the common term. So Brendan, what do you get when you pull out an x out of the bottom? I'm going to leave the top unchanged. Don't try to factor it.
Is it x squared plus 2x plus 1?
Alright, is that factorable? It better be, or we can't do this problem. So Brendan, what is the factored form of that?
X plus 1 squared.
X plus 1 times x plus 1. I'll write it like that, although it is x plus 1 squared. Actually, I think I like it better, x plus 1 squared. Alright. Let me show you the decomposition of that. It's a little different when we have a repeated factor. Notice up here, over here, the factors were different from one another, but here we had one that was just like itself. So we have repeated factor. I'll show you how it decomposes, and you tell me. So the complication I've introduced is in the denominator there's a repeated factor. I will show you how it decomposes, and you tell me how you might explain it to someone, because I'm having trouble thinking how. So a over x, probably you expected that, but look what happens next when we decompose. It's b over x plus 1, and we're going to go on. Any guesses, Johnny, what might be under c?
X plus 1.
Nope.
X plus 2.
No.
X minus 1.
No.
0.
No. How do you divide by 0? Believe it or not, it's that. And you might say, why? Because it is. I don't have a why answer to that. But the fact that this can be written by an equivalent expression like this fairly easily, and it's easy to integrate, so we do it this way. So how can I explain that to someone? When there's repeated factors, the repeated factor will appear first as the lowest degree of the repeated factor, x plus 1 to the first, and then x plus 1 to the second. If there's a third, then it would continue on. So study that. There isn't really any way to foresee its value until you use it and to see that it works. So, alright, so we have to solve this one. Alrighty. We're going to multiply through by I'll take away this integral, we'll just do the algebra right here. We're going to multiply once again by the greatest common denominator, which this case is just x plus 1 squared. So that is the greatest common denominator. Alright, so Gianni, multiply through for me, all that by that, and what do we get?
So it would be 5x squared plus 20x plus 6.
Alright, keep going.
Equals x plus 1 squared.
X plus
A
1.
times x plus 1 squared.
Right.
Plus b times x plus 1.
Alright. Alright, and?
And then plus cx.
Alright. Do you see how he was able to cancel in his mind those factors that he canceled, and then these are the ones that remained when I multiplied through by the greatest common denominator. Okie dokie. Let us, we're going to do the same thing. So Morgan, what do you think? Keeping our eye on the prize. What would be a wise value to pick for x?
Can you do -1?
Yes, you may, because that would be wise. It would zero out this and this term, so that would be very wise. All right, so we're going to do a little bit of the legwork here. It was easier over here when we didn't have much of a denominator, but we have to put in a -1 into this expression. So what's the first term become when I put -1?
5.
And then?
Minus 20
And then?
plus 6.
All right, we'll come back and figure that out in a minute. And so Morgan, what happens to this term and this term?
They both zero out.
Right, and that's why you chose -1 so wisely. And what do we get here?
Minus C.
All right. So we end up with, what's 5 minus 20 minus 15 plus 6? Is that -9?
Yes.
Equals -C, or C equals 9. So fairly quickly, we got this value already. I'll put it in. All right. So, Jonathan, how are you doing? Are you up to the purple?
Yeah. Oh wait. Yeah, I am at the purple.
Okay. Could you try to pick up another value? Morgan kept the eye on the prize here. We're trying to simplify this. What's another value I could pick, Jonathan, for x that would allow us to come up with another one of these unknowns? We're looking for a and b now. This is a 9 as well. What else could I say? Let x equal what? Keeping an eye on the prize. What would be, maybe that wouldn't help that much. I don't see much of.
I was
What
going
do
to
you
say
ask?
0, but I feel like
That's what I was
it would
thinking.
zero out all of them though.
Well, let's just
Wait, so
try
what
it.
are we trying?
We're trying to just pick values for x that when we substitute them in will cause these
Wouldn't
a's
zero
and
be a
b's.
good
A.
thing to use? Yeah, because you can find A then.
I forgot that you could find A still if you use 0. Because it would be 1 squared.
All right, let's try it. All right, Brendan, put in x equals 0. What do we get? All the way across.
6.
If it doesn't lead
Equals-
to anything, we'll come back and try something else. What about this?
6 equals 1.
Pardon?
1.
A times 1.
1.
A.
A.
All
Yeah.
right. And when I put an x equals 0 there
0.
and there.
0.
All right, so that was great. We got A. And that's what you tried to tell us. Somebody did. All right. So we go back here, and this is a 6. And this is a 6. All right. What are we going to do to get the B? Probably. So we're looking at this expression. Just pick another number that's fairly, it's not going to be a perfect number where it zeros terms out, but just a small number that we can fairly easily work with. So, Gianni?
1.
All right, that's what I would have put. Let x equals 1. So Gianni, plug that in, and what do we get over here?
5 plus 20 plus 6.
And what is that?
31.
31. Okay. So then over here we get,
It would be plus 4. 6 times 4 should be 24.
1, 2, 4, 24. Okay. And then?
That would be b times 2
2b. And,
plus 9.
all right, so that works. Now we just have to finish that. So what's 31 minus 24? 7, right? And then 7 minus 9 is minus 2. Am I getting that right? And I got b equals minus 1. Let me check that before I want to go back to integral land. For this one, we got a is a 6. That's correct. C is a 9. Correct. And b is a minus 1. So we did good. All right. There is no wrong answer for what you let x equal. Let x equal minus 1. But there are wiser ones than others. Some just lead to nowhere and some lead to the answers. All right, so I'm gonna go all the way back to here and put in the b, and that's minus 1. And so this is what I'm gonna integrate now that I've decomposed that fraction. So,
Miss
where are
Powell,
we?
it's been 10 minutes.
All right, we're just gonna finish it.
Okay.
All right, Morgan, can you tell me the integral of these three expressions?
Yeah, I think so.
All right, I'm gonna try to squeeze it in here in another color.
Well, can't you pull out the 6?
Yes,
So just 1 over, 6 on the outside.
right. No,
Oh, wait, no, it would just
it
be
just
6.
goes across as a 6.
Yeah, and then is it ln of x?
Right. Then what?
If you pull the negative out, then would it be negative ln of x plus 1?
Right. All right, here we have a u to u. So Morgan, what's the u?
X plus 1.
All right, if u is x plus 1, and what's du?
1.
Right, so dx, 1 dx. So that, we don't have to make any adjustments, but this is u raised to the 2 in the denominator. So it's really a 9 times the integral of u to the minus 2 du. So Morgan, what's the integral of u to the minus 2?
U to the 1.
Minus 1?
Yeah, I think so. Right?
When you
I'm
add,
messing it up.
when you integrate, you add
Yeah.
and
U
then
to the
divide by
minus
that
one,
new
okay.
number. So what would it be?
U to the minus 1.
Over?
1.
No, because it's over that new exponent. So it's u.
Oh, U to the minus 1 over negative 1.
Right,
Okay.
right. So I'm going to put that bottom negative 1 out here. So I have u to the minus 1. U, you said, was x plus 1, but since it's to the minus 1, it shows up there. And where'd my 9 go? All right, plus c. All right, these are things that you can integrate. All right, that's it. I'm going to give the assignment, though, and I guess I'll shine the light on the book. So we'll just...
It's gonna be a long
yeah,
video.
maybe, yeah, why don't you close it down and I'll give